Good morning, sir. My name is K. Sajmar and my roll number is 234G1804999 and subject name is Analog and Digital Communication and subject code is 23EC403 and my branch is Electronics and Communication Engineering and my topic is binary phase shift keying BPSK and quadrature phase shift keying QPSK. How phase changes occur digital data. Introduction to phase shift keying. Phase shift keying is a modulation technique used in digital communication. It conveys data by changing the phase of a carrier wave. Two common types of PSK are binary PSK BPSK and quadrature PSK in brackets QPSK. Overview of binary phase shift keying. BPSK uses two distinct phases to represent binary data. Each phase shift corresponds to bit digit 0 or 1. It is considered one of the simplest forms of phase modulation. BPSK phase representation. In BPSK, a phase shift of 0 degrees represents a binary 0. A phase shift of 180 degrees represents a binary 1. This simple phase representation allows for effective data transmission. And advantages of BPSK. BPSK is highly robust against noise and interference. It requires a lower bandwidth compared to other modulation schemes. Its simplicity makes it easy to implement in hardware. And advantages of BPSK. BPSK is highly robust against noise and interference. It requires a lower bandwidth compared to other modulation schemes. Its simplicity makes it easy to implement in hardware. Limitations of BPSK. BPSK has lower data rate compared to higher order PSK schemes. The binary nature limits the amount of information transmitted per symbol. It may not be suitable for high capacity communication systems. Introduction to quadrature phase shift keying QPSK. QPSK is an extension of BPSK that uses 4 distinct phases. It can transmit 2 bits of data per symbol instead of 1. This modulation technique is widely used in digital communication systems. QPSK phase representation. In QPSK, phases are spaced 90 degrees apart, representing 4 combinations. These combinations are 0 0 in brackets 0 degrees, 0 1 in brackets 90 degrees, and 1 0 in brackets 180 degrees, and 1 1 in brackets 270 degrees. Each phase shift encodes a pair of bits, increasing efficiency. And these combinations are 0 0 in bracket 0 degrees, 0 1 in bracket 90 degrees, and 1 0 in bracket 180 degrees, and 1 1 in brackets 270 degrees. Advantages of QPSK. QPSK effectively doubles the data rate compared to BPSK. It is still robust against noise while providing higher capacity. The 4-phase system allows for efficient bandwidth usage. And limitations of QPSK. QPSK is more complex to implement than BPSK due to additional phases. Increased phase shifts can lead to phase ambiguity in certain conditions. It may require more precise synchronization in the receiver. And phase changes in digital data. In both BPSK and QPSK, phase changes occur at symbol boundaries. Each phase change corresponds directly to a change in the transmitted data. Accurate detection of these phase changes is crucial for data recovery. And limitations of QPSK. QPSK is more complex to implement than BPSK due to additional phases. Increased phase shifts can lead to phase ambiguity in certain conditions. It may require more precise synchronization in the receiver. Phase changes in digital data. In both BPSK and QPSK, phase changes occur at symbol boundaries. Each phase change corresponds directly to a change in the transmitted data. Accurate detection of these phase changes is crucial for data recovery. Receiver design for BPSK and QPSK. Receivers for both schemes must accurately detect phase shifts. Synchronization techniques are employed to minimize errors. Various algorithms such as the Costas loop help in phase detection. Applications of BPSK. BPSK is commonly used in satellite communications and RFID systems. It is suitable for low data rate applications due to its robustness. Many wireless standards incorporate BPSK for reliable transmissions. And applications of QPSK. QPSK is widely used in digital TV broadcasting and cellular networks. It is favored in systems requiring high data rates without excessive bandwidth. QPSK is also utilized in satellite and wireless communications. And applications of QPSK. QPSK is widely used in digital TV broadcasting and cellular networks. It is favored in systems requiring high data rates without excessive bandwidth. QPSK is also utilized in satellite and wireless communications. And conclusion. Understanding BPSK and QPSK is essential for modern digital communication. Both modulation schemes utilize phase shifts to convey data effectively. The choice between BPSK and QPSK depends on the specific communicate requirements. This presentation provides a structured overview of BPSK and QPSK, focusing on their principal advantages. And finally, thank you, sir.